Africa is splitting in two right now, an incredible geological drama unfolding before our eyes. The ground beneath us isn't as solid as it seems. Earth's outer layer, the lithosphere, is made of large plates that float on a semi-fluid mantle below, moving slowly like your fingernails grow. Though slow, this movement causes immense pressure that can crumple mountains and split continents. Africa, once thought stable on one plate, is breaking apart along the East African Rift System, EARS. This rift runs over 2,100 miles from the Red Sea to Mozambique, about the distance between New York City and Denver. It's not a simple crack, but a complex zone of faults, volcanic activity, and shifting land that has shaped Africa's landscape for millions of years. Mount Kilimanjaro and Mount Kenya, iconic African peaks, were formed by this rifting and its volcanic activity. The rift started around 25 million years ago and remains active today. Scientists believe Africa is slowly splitting into two plates, the Nubian plate to the west and the Somali plate to the east. This ongoing process will reshape Africa's geography, climate, and maybe even its political borders in the future. We are witnessing the early stages of Earth's newest ocean forming, with enormous consequences for the continent. Africa is breaking apart along a giant rift stretching over 2,000 miles. What do you think life will be like in this new landscape millions of years from now? The East African Rift is more than just large. It is a powerful force shaping Africa's landscape over millions of years. This rift has created stunning features like the snow-capped Kilimanjaro and the Great Rift Valley. A rift system forms when Earth's crust is pulled apart but doesn't break cleanly. Instead, it creates a complex pattern of faults, volcanic vents, and sinking valleys, like slowly tearing fabric with frayed edges. This ongoing process has created unique ecosystems. The rift valleys have fertile soil from volcanic ash, supporting agriculture for millions. The region is geologically active, with frequent earthquakes and occasional volcanic eruptions. Hot springs and geysers reveal the intense heat beneath the surface. Importantly, the rift has influenced human evolution. Some of the most significant early human fossils were found here. The environment shaped by the rift offered diverse habitats that helped develop human traits. It also shaped migration, trade, and culture by forming natural corridors and barriers. Rift lakes like Victoria and Tanganyika provide vital water and transport routes. The East African Rift is still active, and new research shows it is evolving faster and in more dramatic ways than once thought, raising important questions about Africa's future geography and life. In March 2018, an enormous crack suddenly appeared in southwestern Kenya, stretching for several kilometers and swallowing a section of the Nairobi-Narok highway. Drivers were shocked to find their route blocked by a massive chasm, wide enough to swallow a car and deep enough that the bottom wasn't visible. Photos and videos of this fissure went viral worldwide, sparking doomsday theories and fears of Africa splitting apart. This dramatic event reignited global interest in Africa's geological future, offering undeniable proof of powerful forces beneath the continent. It was impossible to ignore or dismiss. However, scientists quickly clarified that this crack wasn't a new split caused directly by continental rifting. Instead, it revealed a more complex story. Geologists found that the fissure was a pre-existing crevice filled with volcanic ash from past eruptions. This ash created a seemingly solid surface that was unstable beneath. Weeks of heavy rain saturated the ash, destabilizing the ground and causing it to collapse, exposing the hidden crack beneath. This sudden collapse resembled a large sinkhole, but on a grand geological scale. Though this event was not directly caused by the ongoing continental rift, it occurred in a region influenced by the East African Rift System, a geological force slowly pulling Africa apart. The fissure's emergence symbolized the dynamic and often unpredictable geological activity beneath the surface. More importantly, the Kenyan crack highlighted how geological changes can be sudden and dramatic despite the slow pace of continental rifting over millions of years. Landscapes can transform overnight, infrastructure can be destroyed in minutes, and communities can face unexpected geological challenges. This event was a vivid reminder of the powerful and active forces shaping Africa's land today. If you enjoyed this video, be sure to subscribe and hit the bell so you don't miss any future episodes. Don't forget to share this video with your friends. It helps support the channel, and I'm excited to continue bringing you more great content. A continent splitting in two sounds impossible, given its massive size and solid rock, but it happens through forces deep inside the Earth. Beneath the rigid tectonic plates lies the hot, semi-fluid mantle, which moves slowly like thick honey due to convection currents. These currents drive the movement of the plates above. In East Africa, superheated plumes of molten rock rise from deep within the mantle. These plumes push the lithosphere upward and stretch it like inflating a balloon. As the crust thins, it becomes more likely to crack, similar to stretching pizza dough until it tears. This stretching creates a network of faults and fissures along the East African rift. From above, these appear as long, deep cracks and lowered basins separated by higher ground, forming a complex geological fracture system. Volcanic activity accompanies this process, with large eruptions called flood basalts. Instead of cone-shaped volcanoes, lava emerges through wide cracks, flowing across the land like rivers of fire. This volcanic activity shows that the crust has thinned enough to let mantle material reach the surface and helps weaken the crust further, promoting rifting. Importantly, this volcanic rock fills the gaps left by the splitting continent. Over time, this builds new crust, which will eventually form the floor of a new ocean. This is the birth of a new land, as the old continent pulls apart. All of this is driven by heat inside the Earth, created by radioactive decay and leftover heat from its formation. The mantle's convection currents move this heat and cause the plates to shift. Africa sits over one of the most active regions of this global heat engine, making this rifting process particularly dramatic and ongoing. We can precisely measure Africa's continental breakup in real time using advanced GPS technology. Unlike everyday GPS, these scientific instruments detect movements smaller than a human hair, tracking the Nubian and Somali plates as they slowly pull apart. The plates are diverging at about 0.2 of an inch per year. This speed may seem slow, you grow your fingernails faster, but over millions of years it adds up. In a human lifetime of roughly 80 years, the plates move apart about 16 inches, less than 1.5 feet. Not much, but over 1 million years, that grows to over 3 miles, and in 10 million years, about 30 miles. Since this has been going on for 25 million years, the total separation could reach hundreds of miles. This rate is actually fast geologically. Most tectonic shifts happen more slowly. The fact that we can measure this easily shows we're witnessing an extraordinary process in Earth's history. The rifting rate varies along the fault. Near the Red Sea, where rifting is more advanced, movement reaches up to 0.8 of an inch per year. This uneven pace means the rift doesn't open like a zipper but tears irregularly, with some parts moving faster or slower. GPS data also reveal that movement isn't steady. The plates sometimes speed up, slow down, or even pause before moving again. This irregularity reflects complex forces behind rifting, which scientists are still studying. Furthermore, movement isn't only horizontal, land rises and falls too. Mantle plumes push some areas upward, while crust stretching causes others to sink. This vertical motion shapes East Africa's dramatic landscape of tall volcanic peaks and deep valleys seen today. Africa's geography could change dramatically in the future as the rifting process continues. In millions of years, the Horn of Africa, countries like Somalia, Ethiopia, and parts of Kenya, may break away from the continent, forming a new ocean basin as the Indian Ocean floods the Rift Valley. This new sea could rival the Red Sea in size and importance. Such a transformation would have huge effects on the region's nations. Landlocked countries like Uganda and Ethiopia could gain coastlines and access to the sea for the first time. This would revolutionize their economies, allowing them to develop ports and become key players in maritime trade. The geopolitical impact would be profound. Beyond economics and politics, the new ocean would reshape climate and ecosystems. Arid regions could become more humid with access to ocean moisture. Coastal climates tend to be milder, with more rainfall and stable weather patterns, potentially transforming drought-prone areas. This shift would also affect wildlife and vegetation. Waterways connecting previously isolated ecosystems could promote species mixing and create new ecological communities. We might see new coral reefs, coastal wetlands, and rich marine life forming in areas currently far from the ocean. The new coastlines could become vital breeding and feeding grounds, increasing marine biodiversity. The mix of fresh water from the continent and salt water from the ocean might create unique habitats supporting new life forms. It's important to remember this is a slow process. The full separation of East Africa may take 5 to 10 million years, around 200,000 human generations. While we can observe the rifting today, none of us will see its final result. Our species might even evolve significantly by then. Still, witnessing this ongoing geological event is remarkable. We are seeing the birth of a new ocean, one of Earth's most significant geological transformations, unfold in our time. What's your take on Africa slowly splitting apart? Drop a comment and share how you think this epic geological event could shape our future. Continents splitting apart may seem incredible, but this process has happened many times in Earth's history. Our planet constantly reshapes itself, and Africa's rifting today is just the latest chapter in this long story. The most famous example is the breakup of the supercontinent Pangaea about 175 million years ago. Back then, all today's continents were joined in one massive landmass surrounded by a single ocean. Over tens of millions of years, forces pulled Pangaea apart, forming the Atlantic and Indian Oceans and shaping today's continents. South America and Africa's coastlines still fit like puzzle pieces. Matching rock formations and fossils prove they were once connected. This breakup process helps us understand what's happening in East Africa now. We can see rifting at different stages around the world today. The Red Sea and Gulf of Aden are more advanced rifts where the crust has thinned so much that ocean water flooded in. The Red Sea, separating Africa and Arabia, is widening at about 0.6 of an inch per year, faster than the East African rift. This shows what East Africa might look like millions of years from now. The Gulf of Aden formed as the Arabian Peninsula slowly moved away from Africa, flooding the gap with ocean water. The Atlantic Ocean, with its mid-Atlantic ridge, is the final stage of rifting. Here, new ocean crust forms as continents move apart by about 1 inch per year, pushing the Americas away from Europe and Africa. By studying these examples, scientists recognize a clear pattern in continental rifting: rising and stretching crust, fault formation, volcanic activity, widening gaps, flooding by seawater, and eventually new ocean creation. These processes now seem to be happening faster than in the past, possibly due to changes in Earth's internal heat or because we live in a particularly active geological time. East Africa's rift is unique because it cuts through the middle of a continent, making its effects especially dramatic for people and ecosystems. This ongoing event is shaping the future of the continent in ways we are just beginning to understand. Despite strong evidence and advanced technology tracking Africa's splitting, many uncertainties and debates remain in the scientific community. Science evolves by questioning and refining ideas, and the future of the East African rift is no exception. A major question is whether the rifting will continue steadily, speed up, slow down, or even stop. Some scientists suggest the current rifting could be a temporary phase that might halt before fully dividing the continent. The geological record shows many failed rifts that started but never finished. There is also debate about what drives the rifting. The popular mantle plume theory explains rising hot rock pushing the crust apart. However, some argue that stresses from distant plate movements, like India colliding with Asia to form the Himalayas, may also contribute. This global tectonic system means events far away can influence Africa's rift. Surprisingly, climate might play a role too. Changes in rainfall affect surface water weight, which influences crustal stress. During ice ages, heavy ice sheets depress the crust and their rebound after melting can trigger geological shifts. Some scientists explore whether changing precipitation in Africa impacts rifting. These complex interactions add uncertainty to predictions about the rift's future. And climate change, natural or human-driven, could affect the speed and path of continental breakup in ways we don't fully grasp. This makes ongoing research vital. Modern tools like seismic monitoring and satellite imaging gather detailed data on earthquakes, volcanic activity, and ground movement. Dense seismic networks across the rift detect tiny quakes and reveal underground processes, greatly improving our understanding. Satellite images track landscape changes over time, and radar satellites measure ground shifts with millimeter accuracy. Together, these technologies provide unprecedented insight into how the East African Rift is evolving, showing that while we understand much, there is still more to learn. Though Africa's splitting is a slow geological process beyond human lifespans, it already affects millions today. The East African Rift system shapes fertile rift valleys with rich volcanic soils, supporting vital agriculture in countries like Kenya and Ethiopia. Living in an active rift zone brings risks. Frequent earthquakes, mostly minor but sometimes destructive, pose threats to buildings and crops. Volcanic eruptions, like the 2007 Oldonyo Langai event in Tanzania, have forced evacuations and caused economic damage. Yet these same forces create opportunities. Rifting concentrates valuable minerals such as gold and copper, supporting local mining industries. It also empowers geothermal energy production. Kenya leads the world in geothermal power, generating over 40% of its electricity from steam tapped along the rift. Scientists estimate the region could produce thousands of megawatts, potentially ending energy poverty and enabling power exports. Looking ahead, newly formed coastlines could reshape economies and politics. Landlocked nations gaining sea access might gain trade advantages, but changing borders and resources could spark geopolitical tensions over territory, fishing, and mining rights. Socially, communities may face disruptions as traditional lands shift. Long-standing migration and cultural patterns could change as the continent's landscape reshapes beneath them. In sum, the East African Rift is a powerful geological force with profound impacts on agriculture, energy, economy, politics, and society today and in the future. Want to stay on top of Earth's evolving geology and amazing natural wonders? Subscribe now and join our exploration. The East African Rift is part of a vast global tectonic system that connects geological activity across the planet. It belongs to the larger Afro-Arabian Rift system, stretching from Turkey in the north to Mozambique in the south. This giant rift acts like a slow geological zipper, gradually pulling apart large parts of the region. The northern sections, including the Red Sea Rift and Gulf of Aden, show what East Africa might become in millions of years, where ocean waters flood thin continental crust. The Afro-Arabian Rift links to mid-ocean ridges, underwater mountain ranges where new oceanic crust forms, making it part of a continuous global zone of spreading. On a bigger scale, Africa's rifting fits into Earth's ongoing tectonic reshaping, where continents break apart, collide, and merge over billions of years. While Africa slowly splits, other monumental processes occur worldwide. For example, India's collision with Asia, ongoing for about 50 million years, pushes up the Himalayas and Tibetan Plateau. The Pacific Ring of Fire marks where ocean plates descend beneath continents, causing volcanoes and earthquakes around the Pacific Ocean. These tectonic events are interconnected. Forces driving African rifting may be influenced by distant subduction zones or the India-Asia collision. Earth's tectonics form a complex, planet-wide system where every movement affects others. This global view shows Earth is far from static. The ground beneath us is part of a dynamic system constantly reshaping itself. The African Rift is a particularly dramatic example of these forces, offering scientists key insights into tectonic activity worldwide. Africa's potential splitting is one of the most remarkable geological events happening today. It shows how dynamic and ever-changing our Earth is. This slow separation isn't just breaking land, it's the birth of a new ocean, the creation of new nations, and a major reshaping of a vital continent. The East African Rift system affects life in many ways. Advanced GPS technology tracks tiny movements, while volcanic landscapes mark the rift's path. Fertile valleys feed millions. The rift brings both opportunity and risk, creating resources but also instability. It offers a glimpse into Earth's past and its future. Decades of research and technology have made it possible to understand and measure this process in real time, something once unthinkable. Yet, this event spans millions of years, and we are witnessing only a brief moment in a vast geological saga. Studying the rift deepens our knowledge and respect for our planet. The ground beneath us isn't fixed but a living, shifting system, and we are lucky to see one of its greatest transformations. Africa's split is more than a geological curiosity. It's proof that the Earth is alive and full of surprises. What do you think about Africa possibly splitting into two continents? Does it excite or worry you? If you lived in East Africa, how might this change your life? What other geological events fascinate you? Share your thoughts below. Thanks for being with us. Leave a comment, like to show your support, and remember to hit that subscribe button for more exciting videos. See you next time.